Hello everyone. Today is a continuation of our last video uploaded to YouTube in the name of Newton laws of motion. This is our second part, and let us continue and see various types of theories that we have to learn in this lecture. First of all, conservation of linear momentum. See, these two particles, let us say object A and object B, are moving in the right hand side with initial velocity u1 and u2, mass is m1 and m2. After some time, A collides with B and they separated out, and it gained, A gained some velocity, let us say v1, and B gained some velocity, let us say v2. So this is the condition for before collision and this is the condition for after collision. Conservation of linear momentum says that conservation of momentum before collision should be equal to momentum after collision. This theory comes from Newton's third law of motion, where action and reaction equal and opposite. From that we can prove that, see, momentum before collision. So what is the momentum before collision of objects in m1 u1? This is m2 u2. And what is the momentum after collision m1 v1 plus m2 v2? We can prove conservation of linear momentum from second law also. See, we know F equals to rate of change of momentum. If no external force applied, that is 0 equals to dt by dt. So from differentiation concept, we know if there is something within the derivative. So if the derivative is 0, that means p should be constant. So this thing came from our second law of motion, and this thing came from our third law of motion, that is Newton's third law, and this is second law. From second law we can say that p is constant. Now what do you mean p is constant? That is, we can say that momentum is constant. Total momentum is constant, that is constant. That is, we can say that momentum is conserved. And from third law we can say that, see, here momentum is conserved means in the left hand side we have plus sign and minus sign. Total addition is constant. So in this thing we can say that momentum before collision equals to after collision. If you take the whole thing towards the left hand side, then you can see that total momentum is constant, 0. So there is an application in linear momentum, that is recoil of a gun. See, here is the gun, it has mass capital M, and the bullet has mass small m, and it has velocity small v, and the gun, after recoiling, the gun achieves a velocity capital V. Let us say there, see, bullet attached with a gun, both of them are rest at initial condition, right? So after firing they gain some velocity, both of them. V velocity gained for the bullet, and it from third law we can say that the gun should apply, the bullet should apply a reverse force in the opposite direction. So that's why the gun also gains some velocity. Let us say capital. So momentum before collision. So momentum before collision, before firing, we can say that momentum before firing is equal to momentum after firing. So what is the momentum before firing? Both of them are at rest. So u1 is 0, u2 is also 0. So this left hand side is 0. So we have only right hand side. That is m into small v plus m into capital V. So take of common and calculate the capital V or small v. Calculate small v or capital V, because mass would be given. Any one of the velocity would be given in the question, and you have to find out the other velocity. So this type of problem is extremely important for your board level. See, while firing a bullet, the gun should be held tight, because we have just seen that, see here, there is a minus sign, right? There is a minus sign. What does it indicate? It indicates that both of them, capital V and small v, are in the opposite direction. So if you don't hold tight with your shoulder, then it should be, then it has a recoil velocity. The gun should have a recoil velocity. So it will, there is a chance that it will get hurt, right? And the second most important application from the conservation of momentum is your rocket and jet plane. We learn it after some time. Now another application is explosion of bomb. We will see a problem related to explosion of bomb and how we can apply the conservation of moment. So let us see one problem related to collision. A body of mass 1 kg initially at rest. Let us say 1 kg mass is initially at rest. Here, let us see. At rest explodes and breaks into 3 pieces, 3 fragments of masses in the ratio. See, their masses m1 into m3 is given. 2 pieces of equal mass fly off perpendicular to each other with a speed of 30 meters per second. What is the velocity of heavier fragment? So let us see, initially the bigger mass is here. And after explosion, it has 3 pieces. Equal mass. See, here you can see that it is given that the mass ratio is 1:1:3. So that means we can take it as m1:m2:n3, that is 1:1:3. And it is given that the total mass is 1 kg. So you can say that m1 plus m2 plus m3 is 1 kg. After solving from the ratio concept, we can assume that m1 is 1m, m2 is 1m, m3 is 3m. So total addition is 1. You can find out the value of m. After putting the value of m here, you can find out the individual masses. Yes, m1 and m2 have equal masses, which is 0.2, and m3 comes up to be 0.6 kg. And it is given that each other the equal masses separate away at 30 meters per second velocity. You have to find out the bigger fragment. Let us say the bigger fragment has a velocity v3. So let us say bigger fragment goes in this direction with a mass m3 and velocity v3. And these equal masses, m1 and m2 have equal masses. We can see here m1 and m2 has equal masses, m and m. They have gone with a perpendicular direction. So if it has to be perpendicular, then each of them has to go with 45-degree angle. So let us say this mass has velocity v1 and this mass has velocity v2. So what is the momentum? Momentum is m1 v1. But we have to apply. See, the concept we have learned in linear momentum is that it should go in a line. It should be in a line. So m1 v1 is the momentum in this direction. You don't need that. The 45-degree angle is attached to m1 v1. So it has a cos component, m1 v1 cos 45 in the positive x-axis, and it has momentum m2 v2. So it should have cos component in the positive x-axis. That's why there are 2 arrows. So in the right hand side we have m1 v1 cos 45 and m2 v2 cos 45. And in the left hand side we have only m3 v3. So from the conservation of linear momentum, we can say that the total momentum is conserved, and the right hand side momentum is equal to left hand side momentum, or we can say momentum before collision should be equal to momentum after collision. The momentum after collision is in the right hand side direction, m1 v1 cos 45 plus m2 v2 cos 45, and it is in the left hand side direction. So it should be minus m3 v3, and initial mass is at rest, so velocity 0. So 0 something equals to this. Please take the m3 v3 in the right hand side. So it should be minus m3 v3. That should be equals to 0. So from there, if you take m3 v3 in the left hand side, you can say m3 v3 should be equals to m1 v1 cos 45 plus m2 v2 cos 45. Put all the values, you will get the velocity of the bigger fragment as 14.14 meters per second. Let us move forward. Say equilibrium of constant forces. If we concurrent forces. If we apply 3 forces, let us say in this case we have applied 3 forces, but in other cases maybe we have applied 4, 5, 6, another any force. So if you apply 3 forces at one point, those forces are known as concurrent forces. At same point, that is concurrent. So let us say in this direction we have applied F1 force, in this direction we have applied F2 force, in this direction we have applied F3 force. So if you take parallelogram law of addition, you can take the resultant vector F1 plus F2 in this way. So from this diagram we can say that F1 and F2, F1 plus F2 and F3 has opposite direction. So we can say F3 is in opposite, so minus F1 plus F2. Take everything in the left hand side, so F1 plus F2 plus F3 0. So that means you have learned from this thing that if you have applied n number of forces, those multiplication of all the forces should be 0 for concurrent forces. If you for concurrent forces, addition of all the forces should be 0. Now from in this regard, remember one theorem here, that is, let us say if we apply 3 forces, F1, F2, F3, and angle between them, let us say F3 and F2 angle is alpha, angle between F1 and F2, let us say gamma, and angle between F3 and F1, let us say beta. So according to Lammy's theorem, force divided by sine of the opposite angle. See, here force is F1, angle is opposite, so alpha, sine of alpha. That should be equals to F2, force is here, opposite angle is beta, and F3 is here, opposite angle is gamma. So remember this thing, this is extremely important. Now we will see 1 to 2 problems related to concurrent of forces. This is extremely important. Let us see 2 problems related to concurrent forces. So here the diagram is given. Determine the tension T1 and T2. This tension T1, you have to find this tension and this tension T1 and T2. Here is a weight of 4 kg weight that is given. So this is the weight is given in the gravitational unit, right? 4 kg weight, that is the gravitational unit. Now see, draw a perpendicular horizontal line and see if extend this line. If this is 60 degree, then alternate angle this should be 60 degree. If this is T1, that means the component attached to T1, this should be T1 cos 60, and this component should be T1 sin 60. Now see the this diagram what is given, this is not mentioned, but whenever there is no mention, if they don't mention that the object is in, the system is in equilibrium, you have to keep in mind that the system is in equilibrium. There, if the system has to be in equilibrium, then this upper component, this T1 sin 60 should be equals to 4 kg weight. This T1 sin 60 should be equals to 4 kg weight, and this T1 cos 60 should be equals to T2. This T1 cos 60 should be equals to T2 because they are in equilibrium. So 4 kg weight. So if you see T1 is 4 kg weight by sin 60. Now 4 kg weight, if you want to find it in Newton, then that should be 4 into 9.8, and sin 60 is root 3 by 2. So calculate 45.26 Newton. And if you have already calculated T1, so T1 cos 60 equals to T2, and in this case T2 should be equals to T1 cos 60. So T2 should be, we have already found out 45.26 as T1, so T1 into 0.5, you will get 22.63 Newton. That's all you have to find out. Let us see one straightforward question from Lammy's theorem. A ball of mass 1 kg, so 1 kg weight, here a ball of mass is attached 1 kg weight, and in equilibrium it is given. In this question it is given that the system is in equilibrium from 2 strings, OA, this is OA, this is OA, and OB, this is OB. What are the tensions in string OA and OB? You have to find out the tension, that is T1 and T2 you have to find out. See, for Lammy's theorem, we have to find out the opposite angles, right? So draw a horizontal line here. If this is 60, this should be 60. This thing is in 90, so 90, this is 90. So 90 plus 60, the whole angle is 150 degrees. Now see, this is 60 in this triangle. In this triangle, you can see that this angle is 60, this angle is 30. So this angle must be 90. Total angle in the triangle is 180, right? Now see, if we take this whole circle, this angle is 150, this angle is 90, so this angle should be 120 degrees. So you got all the angles in the concurrent forces. Now calculate. So T1 divided by opposite angle, and that is, I think I made a mistake. T1, let us say this is T1 and this is T2. Yeah. So T1 divided by sine of 150, that should be equal to T2 divided by sine of 120. That should be equal to, this is 1 kg weight, means 1 into, let us say 10, 9.8, we are taking 10, so 10 Newton. So 10 Newton, force is in the downward direction, and opposite angle is 90. So 10 divided by sin 90. So equate T1 by sin 50 to 10 by sin 90, you will get 5 Newton, and then equate T2 by sin 120 equals to 10 by 90, you will get 5 root 3 Newton. So this is the simplest application of Clam's theorem. If you know the Clam's theorem, you don't have to break it into components like this. If you know Clam's theorem and if you can find out the angles in the concurrent forces, then you don't have to break this component and equate the component. You just have to simply apply the component. So let us see another problem. A uniform rope of length capital L resting on a frictionless, this is important, frictionless horizontal surface is pulled at one end by a force capital L. What is the tension in the rope at a distance small h from the end where the force is applied? So you need to find the distance, you need to find the tension. See, this is the scenario. Let us say this is a rope and the length of the rope is capital L, and you have applied a force capital L at one end. And let us say what is the tension in the rope at a distance small h. They want to find out, they ask about to find out the, let us say in small distance L, see, if you have applied F here, that means in the hole where there should be a F force, and in the, from Newton's third law of motion, we know that action and reactions are equal. So if you, let us say, we are considering the distance from small l from the end where F is applied. Let us say here the tension is T and in this direction tension is T, because equal and opposite force Newton's third law, and the rest distance would be L minus L. So let capital M be the mass of the uniform rod of L. In this chain problem, rule problem, this rope problem, always remember, in this type of problem you have to find out the mass per unit length. So let us say mass per unit length of the rope, this rope of mass capital M is, see, in L length mass is capital M. So in unit length mass would be capital M by L. So in unit length mass will be capital M by L. Or it will be the acceleration F by M. So that will be the tension in the rope at a distance small l, as discussed already, T, from end where the force F is applied. The mass of the length, the remaining mass of this waste portion, that is L minus L of the rope, what would be the mass? Let us say M prime. Now we want to find out it in mass per unit length. What is the mass per unit length? Capital M by L. So in capital M by L, that is in unit length, the mass is M by L. So in L minus L length, the mass would be capital M by L into L minus small l. So our mass would be in L minus small l, mass would be M by L into L minus small l. See here, P is the only force. So P should be mass. What is the force? Force is mass into acceleration. What is the mass of the remaining portion? Mass of the remaining portion is M by L into L minus L. So that is our M prime. Into acceleration. What is acceleration? Force divided by mass. So put the values of capital M prime and L by M. Capital M gets cancelled out. Insert this L into this bracket. So it would be 1 minus L by L into F. This is the force which is applied in the remaining portion of the rope. This is the standard type of portion. Always remember this type of portion, rope problem, chain problem, always follow this method. First find out the mass per unit length and proceed as I have written in this. See, motion of connected bodies. In this lecture we will learn something of a little bit of free body diagram, and we will learn a free diagram fully in the lecture of friction. Okay, in the next lecture we will learn friction, and there we will see that how the complete FPD is drawn. See here is a pulley. It is a pulley. It is rotating. The pulley is rotating. always remember that the tension is always towards the pulley. This is a very important point. Tension is always towards the pulley. Tension is always towards the pulley. See, here M mass is attached, here capital M mass is attached, here small m mass is attached. So force acceleration due to gravity is downward. So force here is downward. So here force is mg. Here force is capital M into G, which is downward. Tension is always towards the pulley. So here in this pulley, in this string, see here we have applied the same string. In this string, the tension is upward. As the string is same. Next point. As if the string is same, 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 then tension will also be same. So two important note. See, tension is always towards the pulley. So here tension could be upward, and in this string tension will also be upward because it is towards the pulley. Now see, the string is same. As the string is same, so tension will be same. So here we have written as E and E. Now why these things? How to write this FBD? See, FBD is nothing, free body diagram. That means you have to separate the connected bodies and you have to write down the forces applied on the separate body. If we have separated this object, let us say this mass is capital M, then this weight or force is towards the downward, tension is upward, and acceleration is downward. And if we separate this body, weight is downward, tension is upward, and acceleration is upward. So these things are known as free body diagram. That means the connected bodies are free, and now you apply all the concept in this free body diagram. Before releasing the free body diagram, always remember you have to mention all the forces act on that FBD. Which act in this diagram, you have to write down all the forces act in that diagram also. So from here we can see that, see, acceleration is downward. That means the overall object, that means this object is going downward. So acceleration is downward. Now we see force. Always resolve. Next point. Always resolve force says in x and y direction. In x and y direction separate. That means you have to do summation of, always remember, summation of fx is 0, summation of fy should be 0. That means in the x-axis, the summation of all the forces should be 0, and in the y-axis, that is in the vertical motion, summation of all the forces should be 0. That means, see, here downward force is, downward acceleration is 8. So what is, so net force is towards downward, right? So what is the net force? Force and mass into acceleration. Net force is mass into acceleration. Here, let us say this capital M. So capital M into A. Capital M into A. That is the force which is acting downward. Now what is the net force towards downward? What is the net force? As the object is moving downward, so that means that this mg should be greater than this upward force T. So we can write capital Mg minus T. So this is our first equation. Mass into acceleration should be equal to mg minus T. What is the equation for this free body diagram? See, object is going upward. That means this tension is greater than this force which is acting downward. So we can say T minus mg should be equal to mass into small m into acceleration. See, T minus mg equals to mass into acceleration. So you have to, here we have only in the vertical motion direction, vertical forces. If we have horizontal forces, then you have to equate to horizontal forces equals to 0 also. If you take m in that side, so resultant force will be 0. Or always remember, net force here is downward, so force, so what is the net force here? Mg is greater than T, so Mg minus T should be Ma. Here object is going upward, so net force is upward. So net force is upward, so T is greater than Mg, so T minus Mg should be equals to mass into acceleration. Solve these two equations. At this two equation you will get acceleration. Divide these two equations, you will get tension. So in the question, this type of question, they want to find out, or they will ask you about finding out the tension, finding out the mass, finding out the acceleration, whatever they will ask you. Always remember, you have to draw the FPD, write the equation, solve the equation, you will get everything. Don't have to worry. These things are known as FPD, and in this FPD we have only applied the vertical motion, that is Fy equals to 0. And now we will see 1 to 2 problems before ending this lecture. So let us see another problem in order to clear in the, if there is a sliding problem. See, two blocks of masses 50 kg and 30 kg connected by a massless string. So here it is given in the maximum number of questions, the board level and JEE level. They will the string we have used, we will use is actually massless string. Otherwise it will be for advanced level. Pass over a light frictionless. So in this question there is no friction. Frictionless pulley. This pulley is frictionless, and rest on two smooth planes. Let us say these two planes, inclined at 30 degree and 60 degree, respectively with the horizontal. Determine the acceleration of the two blocks and the tension in the string. So here in this diagram we will see the FPD, how we can draw FPD and how to determine the acceleration and tension. See, here the angle is 30 degree. Always remember, the weight is always perpendicular to horizontal. So that means here weight will be perpendicular to this horizontal. Okay. So this is, let us say this is 50 kg. So weight will be 50 g. Okay. Mass into acceleration, that is your force. The force is 50 g towards the horizontal. Now see, this is 30 degree. This angle is 90 degree. So 90 plus 30. So this would be your 60 degree. So this angle would be your 30 degree. So always remember, this angle and this angle will always be same, that is 30 degree. So if this is 30 degree, if this is 30 degree, this is 50 g, so this component, the attached component would be cos 30. So this is 50 cos 30, and this component would be 50 g sin 30. And here, as the body is attached, lying on the surface, so it will have a reaction force, that is Rho. And in the similar manner, this is your 30 g, this angle is 60, so this angle will also be 60. This angle is attached, so this is 30 g cos 60, and this is your perpendicular component, 30 g sin 60. And let us say the tension is here. Tension is always towards the pulley. I have already told you, tension is always towards the pulley. Here, as the mass is bigger, so obviously the object will go in this direction, the acceleration is in this direction, and the mass is less, 30 grams, so it will go upwards. So acceleration is in the upward direction. Now, under the equation, see here R1 equals to, here this R1 balances with 50 g cos 30, 50 g cos 30, and here see the resultant force. Here in this direction, 50 g sin 30 force is applied, and in the opposite direction, tension T is applied. So what is the resultant force? As the object is moving in this direction, so resultant force would be 50 g sin 30 minus T, that should be equal to mass into acceleration, 50 into A. And in this direction, as the body is moving upward, so T is greater than 30 g sin 60. So what is the resultant force? T minus 30 g sin 60, that should be equal to mass into acceleration, that is mass is 30 into A. Solve these two equations, you will get acceleration and tension. Solve this two equation. See, two equation to one more. I think you can solve this equation. After solving, you will get acceleration is this much and tension is this much. Always remember, resolve the component and equate to force. Resolve the component and equate to force, you will get the answer. So let us see one problem. This will be our last problem, Newton's law of motion. this lecture we will start friction. So see, in this question it is given that find the acceleration of the both the blocks. The diagram is given. Here this string, in this string it is a pulley. The tension is T1, and as the string is same, up to this the string is same. So this tension will also be T1. Now this string rotates upward, so that means this is also the same string as it is given that the tension is T1. Okay, so that means this whole string is same. That's why the tensions are same. But this is another tension. See, it is given that the tension is T2. That means this is another way. And in this string, a mass of M2 is connected. So if you see in this tree diagram, M2, the force applied downwards is M2 into G, right? So how many equations we need to find acceleration in both the blocks? In this type of problem, always remember, see, if this string moves some distance, let us say x distance is moves, this string or this block moves x distance towards right. If this block moves x distance towards right, that means the overall movement of this string in the pulley would be x. Overall moving of this pulley is x. So that means this string moves x by 2 and this string moves x by 2. So always remember, if this string moves x, this string moves x by 2 and x by 2. Total should be x. And acceleration, as the displacement is half, so remember acceleration will also be half here. So in this thing we can say that the block is moving rightward. So this T1 as there is no other forces, right? If there is no other forces, so the block is simply moving rightward, and it is given that the surface is frictionless, so no opposite force is there, and the pulleys are massless. So here you can see from second law that force equals to mass into acceleration. The rightward force is T1. So rightward force is our T1. So T1 should be mass into acceleration. Let us say acceleration is A. So T1 should be mass m1 into A. See here in this diagram, the downward force is m2g, upward tension is T2. So total overall movement is towards downward. So m2g minus T2 should be mass into acceleration. The mass is what? Mass is m2, and what is the acceleration? I have already told you. If this acceleration is A, this whole system acceleration would be A by 2. So mass into acceleration, that is A by 2. And in this diagram, you can also see that upward force is T1, here upward force is T1, and here downward force is T2, because action and reaction are same. So T1 plus T1, that is 2T1 should be equal to T2. So T2 should be equal to 2T1. We already got T1, so this would be 2 into m1. Now from in this equation, m2g minus 2 into T1, that is 2, T2 is 2 into T1, that is 2 m1a, should be equals to m2 into a by 2. Now put all the values, if LCM, put all the values, you can see here acceleration is 2 m2g by 4 m1 plus m2. So acceleration is, for mass m1, acceleration would be 2 m2g by 4 m1 plus m2. Now what will be the acceleration of this object? You already know. If this object's acceleration is a, so this object's acceleration would be a by 2. So acceleration would be a by 2. That is this thing divided by 2 equal to cancel out m2g by 4 m1 plus m2. So I hope you are finding these lectures interesting, and wait for our next lecture of friction, that is laws of motion, to continue. If you are liking this, please like, subscribe and share. Always.